We're going to take a quick look at how to run the Marie computer simulator. When you download the zip file and unzip it, you'll get something that looks like this, except for the programs folder. That's one that I've added since I downloaded the files in the first place. And the one that really matters here is the one called Marie Sim. That's the simulator. It's a jar file, which means that it requires Java in order to run. If you're using a Briarcliff computer, Java should be installed on the Briarcliff computers. If you're not, it's a free download on the internet. We have two versions of the Marie guide. One is a Word document, one is a PDF. Then we have a quick guide, which is shorter, and there's also a doc and a PDF version of that. If you'd like to see the source code for the simulator, this is the source code. It's written in Java. If you don't know Java, you'll have a tough time understanding it. Even if you do know Java, you'll probably have a tough time understanding it as well. And then just a couple of other files up here that we're not going to be too concerned about. So let's go ahead and run this. We'll just double click on it. And here's our Marie simulator. So this is the memory down here. And we have 12 bits of addressable memory, which means we can go all the way up to 4,096 memory cells. In anything that we do in this class, we are not going to have to scroll past the first, 8 or 9 rows here. As a matter of fact, we'll probably never use more than, the first 4, maybe 5 rows at the most. So this is your memory. This is the registers of Marie. We've got a 16-bit accumulator, 16-bit instruction register. The addresses are only 12 bits long, so this is 12 bits. The memory buffer register will hold 1 word of memory, which is 16 bits, and the program counter refers to a memory address, just like the memory address register, so that's also 12 bits. We have a box here. This is not a register. This is used for input. Input on a real computer is a lot more complicated, but they've really simplified it for Marie. We will be inputting, almost all the time we'll be inputting numbers. So we want this to say decimal, and when we output those, we want those to be displayed as numbers as well. So you will almost always have to check these and make sure that they say decimal before you start, otherwise you're going to get some funny looking answers over here, even if your program is doing what it's supposed to do. So we need a program to run. This is where your source code is going to go. We don't have any source code yet, so we have to go to our File tab up here, and we have to choose the editor. The editor is about as simple as you can get. It's a lot like Notepad, and you can just type in instructions here, and if it starts in the first column, it needs to be a label. So we're going to start everything in the second column here, and the second column is just going to tab over, which is usually about 8 columns. And the first thing we're going to do is we're going to start off with a comment. Comment begins with a slash, and it can either be on a line by itself, like I'm doing here, or it can be on the end of a line. Everything from the slash on is going to be disregarded. So I'm just going to put my name up here to get started. And I'm just going to do a very, very simple program here. I'm going to input a number from the keyboard, and I'm going to store that number in a memory cell called A. I'm going to input another number from the keyboard. I'm going to store that in a memory cell called B. And then I'm going to, now B is still in the accumulator from the input instruction, so I'm going to add what's at location A to B. The result goes in the accumulator. Then I'm going to do an output command, and then I'm going to halt my program. And so whatever numbers I put in, it should output the sum of those two numbers. So let's go ahead and we want to assemble the program. It can't be run unless it's assembled and converted into binary. And this is grayed out. And the reason it's grayed out is because we haven't saved it yet. Let's go to our File tab here, and let's do a Save As. And there's one thing I think Marie should do here that it does not do for us, and that is it should automatically put the file extension on, because everything we write in the editor is going to be Marie assembly code. But they don't do that, and you have to remember to do it yourself. So put doc, and then follow it with MAS, which is for Marie Assembler, and then you can click on Save. If I had not put the .mas on the end, the assemble option on the menu would not have been enabled. It would still be grayed out, and I'd have to go back and save it again and make sure to put the MAS on the end. But now that I've done that, I can assemble the program. So let's go ahead and click on Assemble. Assemble current file. And if there's an error in your program, then up here, a new window will open up and it'll tell you what the errors are. The error will be below the line that the error occurs on. And the problem is that we have an undefined operand A. Down here we have an undefined operand B. Down here we have an undefined operand A again. And so the problem with those is that if you want to refer to those are memory locations, and I haven't specified where those memory locations are. And typically you put them right after the last instruction of your program, which on Marie needs to be a halt instruction. So the label goes in column 1. So if you want to refer to a cell by its name or by its label, you have to put a label on the front of it. The label goes in column 1 and it's followed by a comma. And you got to tell it what you're going to put there. And I'm going to put a decimal number 0. So DEC for decimal. And then I'm going to put B. And I need a comma after that. That's also going to be a decimal. And it's going to have the value 0 in it when I begin. And obviously when I input the two numbers, those zeros are going to change to something else. So now let's go ahead and let's save it. And now let's go assemble the current file. And if there are no errors, you don't get the window. All you get is a little message down here that says the assembly was successful. Okay, so I'm going to minimize this now. And I'm going to go into my CPU simulator. I'm going to go to my File tab. I'm going to go to Load. And I'm going to tell it that I want to load junk. Now, the file I saved had MAS on the end for Marie Assembler. And this has MEX on the end, which stands for Marie Executable. So this is an executable file. And that's the only thing you can load. So let's go ahead. If you tried to open junk.mas, you get some serious errors, I'm pretty sure. So there's our program. It just happens to fit in the window here. If it did not fit, you've got scroll bars over here so you can scroll and look at the rest of your code. The labels are over here. The opcodes are here in English, and the operands are here. And over in the last column is the assembled code. The code for input is 5, and there is no operand, so I got 3 zeros. The code for store is 2, and location A is down here at 007, so I want to store something at location 007. Input again, and then I'm going to store it at location 8, which is where B is. Then I'm going to go get what's at location 7. I'm going to add it to what's in the accumulator, and what's in the accumulator is currently B. And then I'm going to output the sum, and then I'm going to halt. So let's go ahead and run the program. Whenever it gets to an input instruction, the input box turns pink and it lets you put in a number, and it will stop. You can't complete the input instruction until you get the enter key, which I'm going to do right now. And now let's take a look. I typed in a 7 and it said store that at location A. Well, location A is location 7 down here, and a 7 just got put in there. And now it's doing the next input instruction. I'm going to tell it I want the 8 to be B. I'm going to hit enter. And the number 8 gets stored down there. And it also does the rest of the instructions very quickly here. It adds A to B and gets 15 in the accumulator, which is F in hex. And it outputs that, but it converts it to decimal, so it becomes a 15, and then it halts. Okay? Now, another thing you might want to do is you might want to single step through your program. If your program doesn't work the first time, you're going to want to go to your Run tab here and say that you want to restart it. It does not reinitialize these values down here, so if they need to be initialized to 0, which in this case they do not, because we're going to write over them right away, but if they need to be initialized to 0 and they're not 0, you can't do that. You have to go to your Run tab up here and say you want to reset the simulator, and we'll say yes to that. And we have to go reload the file if that's the case. So we go back here and we reload junk.mex. We go ahead and open it up. And now if you look at 7 and 8, which are the locations for A and B, we've got a 0 and a 0 there, just like it says up here. So now we're starting completely from scratch again. and I'm doing something wrong. Well, actually, I'm not in this program, but if you're doing something wrong, you want to figure out what it is. A real useful thing to do is to set the stepping mode, and if this is not enabled, if it's grayed out, this is where you go to turn it on or off. So if it's currently on, we can't turn it on again. The only thing we can do is turn it off. So off is the only choice we have here. And now it's grayed out, which means I can't single step. If I go back here and set stepping mode and turn it on, now this is enabled. And if I go over here and click run, though, it just runs all the way through. If I want to slow it down, I click on step. Okay, so it'll do, if I click on step, it'll do the input instruction for me, and I'm going to type in the number 10, which would be an A. Okay, now this one has just been executed. The green instruction is the one that was last executed. The one below it is the one that will be executed next. So I do not have anything out here in location 7 yet, but after I store the 10, I should have an A out there in location 7. Let's go ahead and step, and it did store the 10 out there, which is an A in hex. Now let's do another input, and whoops, I got to click on step, not the instruction. And now let's do 10 again and hit enter. And so that's in the accumulator. I probably should have put something different in so we could see the change, but now I'm going to store that in location B, which is the 8 here. So let's go ahead and step, and this instruction just got executed. The one that's green is the one that just got executed. Okay, the one below it is going to get executed next. So if I add A and A together, that's 10 plus 10 is 20. In hex, that is 16 plus 4, so it should be the number 14 in the accumulator after I click on step here. So there's the number 14. Then I'm going to output it. If I take an output of number 14 and I output that, but I want to convert it to decimal, it'll convert that into the number 20 for me. Let's go ahead and step. There's the number 20. One more step to execute the halt instruction, and now this gets grayed out because the machine has halted and there's nothing further to be executed. So those are the basics of running the simulator using the editor and running the program and doing input and output and stepping through the program one instruction at a time.